I can use the sine ratio to solve for the missing side of a right triangle. Similar approach to our last lesson. Let's go ahead and investigate the sine of 49 degrees in three clearly not congruent triangles. So I'm going to go ahead and write SOHCAHTOA at the top of each of my pages. We're dealing with sines, so I'm going to go with SO. Here's my reference angle. And I'm going to go with my opposite. And my hypotenuse. Okay. So the sine of 49 degrees is opposite over hypotenuse. So in this case, I'm going to be looking at 6 over 8, 15 over 20, and 21 over 28. They all look different. However, if we reduce them all, you're looking at 3/4, 3/4, 3/4. So what can we infer from the examples? The sine of 49 degrees reduces down to 3/4 for all triangles. Let's keep in mind that 3/4 is really equal to 75 hundredths. 3/4 is 75 hundredths. Okay? So they all reduce down to the same thing. And what we're really saying then, when we say the sine of 49 degrees is equal to 3 over 4, or in this case we can say 75 hundredths, what we really mean to say is that all right triangles with a 49-degree angle will always be similar by angle-angle similarity. Okay? Remember, you say sine, cosine, or tangent, you know you're dealing with what kind of triangle? A 90-degree triangle. A right triangle. So you know you have a 90, and now you have a 49. So the sine of 49 of two different triangles is a 90 and a 49. They are similar by angle-angle. Therefore, if we've got two triangles similar by angle-angle, the ratios of the side opposite 49 degrees to the hypotenuse will be proportional. Okay, they're going to be proportional. And remember what proportional means? Proportional really means you're going to equal each other. They'll reduce down to the same thing. Three-fourths equals 3/4. 6/8 does equal 15/20, because when you reduce them, 3/4 equals 3/4. Okay, this over this, this over this is equal to this over this. That's proportional. They're not equal straight up. 6 doesn't equal 15, but if you set up a ratio here and a ratio there, those ratios are equal. So we can go ahead and we can now apply what we learned down here. We have two approaches again, the similar triangles approach or the substitution method. We want to make sure we round to the nearest tenth, don't forget. Let's go ahead though and set up a similar triangle. I need 18 degrees. So here is my reference angle in both triangles. And let's just see really quickly. I have my opposite, my hypotenuse, and all that good stuff. Let's get the hypotenuse set up in both triangles. Here's my opposite. I can put the adjacent in too if I want, but I'm not using the adjacent. That's why I haven't done it yet. And let's see. In this case, it says 32 hundredths. This is 32 hundredths. So I can put 32 over 100 because it's sine. Sine is opposite over hypotenuse. So my opposite is going to be 32, and the hypotenuse is going to be 100. So you can take a look right now, and you can see the ratio x over 8 is going to be the same thing as 32 over 100. So x over 8 is equal to 32 over 100, and then you just solve. Now you'll be tempted here, and these are proportional again because of angle-angle similarity. They're not equal. Okay, 8 doesn't equal 100, but you set up the fractions, the ratios. They're going to be equal to each other. They'll reduce down to the same thing. So I'm going to go ahead and cross multiply. I'm not going to reduce first. And the reason is 8 times 32, I might have to go do that off to the side. That's 240, 256. I love dividing by 100 or by 10 or by 1,000. So that's why I didn't reduce, because I knew I'd be able to divide by 100 here. Now I'm going to move the decimal point 1, 2, 0, so 1, 2 places. So my x is going to be 2 and 56 hundredths, but I'm not done because I need to round to the nearest tenth. And so I look here, I want to round to the tenths. I look to the right, I see a 6, so I'm going to round up. So it's approximately equal to 2 and 6 tenths. Here's the other method. I'm just going to set it up. You take this, you rewrite it. Rewrite this as a fraction though, 32 hundredths. Sine of 18 in this case is opposite over hypotenuse, so you get x over 8. And then you solve it the exact same way you did. Again, all I did was ask myself, what is the sine of 18 in this triangle here? And that's how I got those, x over 8, sine of 18. You can go ahead and check against your own, hit pause. Okay, here I go. I'm going to go ahead and write out sine of 22 degrees is equal to 37 hundredths. This now I'm going to rewrite as a fraction though, 37 hundredths. Sine of 22 degrees though, let's see, 22 is my reference angle. My opposite is here. My hypotenuse is here. And I'm using sine because they gave me sine. Sine of every 22 degree angle is 37 hundredths. So let's see, what is the sine of 22 here? It's opposite over hypotenuse. So that is going to be x over 6. And now, go ahead, cross multiply 100x, 6 times 37, I might have to go do off on the side. That's going to be 180 and 42, and that's going to be 222. And then I'll divide both sides by 100, so I'll move the decimal point 1, 2, 0, so I'll move the decimal point 1, 2 spots. Therefore, x is equal to 2 and 22 hundredths. However, I want to round to the nearest tenth, so I'm going to go ahead, here's the tenth spot, I look to the right, I'm going to round down, so this is approximately equal to 2 and 2 tenths. Good luck.